Okay, so welcome all the students here, and here you are here present mainly for one concern that we'll be doing the syllabus of mathematics, which is 4024 O levels mathematics syllabus D, and we are here to tackle different problems which the student can have and to do or to go through the entire syllabus of mathematics. So basically, I will start with every topic, and that topic will be started with the 0 level. That means you people will have the possibility, the chance to get to know all the things that you have to do in your syllabus. And that will be a good thing for you people. Starting with the first one. You are already aware that the students who are appearing in mathematics syllabus D 4024 code, they are actually the students who are appearing in CAIE examination, Cambridge Assessment International Examination. And basically, when a mathematics paper is there, it comprises of two papers, P1 and P2. P1 will have a time duration for the paper as 2 hours, and P2 will have the time duration of 2 hours and 30 minutes. I'm just revising this basic things also because many students must have been still there who might have some confusion related to the paper 1 and paper 2. So that will be decided today. And afterwards, it will be revised somewhere in between when you will get to know the things. And we will be doing the syllabus. 2 hours paper duration for the P1, 2 hours and 30 minutes paper duration for P2. P1 is of 80 marks, while P2 is of 100 marks. In P1, you normally get questions at least 18, maximum 28. And you have to do all the questions, you have to attempt all the questions. While in paper 2, you get 11 questions, and again, you have to attempt all of them. There is no choice. When you attempt the questions, you will find out that the syllabus which we have to cover in paper 1 as well as paper 2, they are exactly the same for both. There is no difference in that. You have to do entire syllabus when you are going to the paper 1. And again, you have to do the entire syllabus, that is revise entire syllabus when you go for the paper 2. Paper 1 is of non-calculator version. That means you can't use the calculator. Therefore, you get those questions which can be done mentally, or we can do them with some process taken, and then afterward we can easily do the solution of that. While in paper 2, we have the calculator version. That means we can use the calculator. Therefore, the questions are a bit more difficult than the paper 1. So let's start with the situation that we have the paper, the syllabus. In the syllabus, you get 60% of the syllabus in which you are involved with some kind of calculations, while 40% is again divided into the 30% and 10% situation. That is 30% is related to the graph and graphical calculations, while the rest of the 10% are related to the construction. Construction in which we use the constructional instruments, that is ruler, pencil, compass, and protractor, and we do the accurate drawing. So we have to manage all these type of situations when we are doing the preparation for the paper 1 and paper 2. So today as the first class, I'm starting with the first topic, and that topic is the most important one, without which you can't do the maths paper, and that is called numbers and everyday maths. Moreover, whenever you find any difficulty in any one of the lecture, you should send the queries on the group, the WhatsApp group, where we will definitely gather all the queries, and those queries will be resolved in the next class, because we can't take the queries every day during the lecture. In this way, the lecture will be interrupted and it will be difficult for me to complete the syllabus. So whatever your queries are, you will send your queries with your names on the group, and there we will assemble all the queries and that will be discussed in the next class. So I have taken right now the topic numbers and everyday math. And why I said that it is a very important topic and I have taken it as the first topic, that is only because in every calculation of mathematics, there are numbers and everyday mathematical calculations involved. And that is not only in the questions which are related to the fractions, decimals, or the BODMAS method type, but they will be involved in the geometry as well as the graph, as well as any type of thing or any type of the topic that we are going to do that related to the syllabus, as far as we know that we are completely derived to the mathematics syllabus, including algebra, geometry, and mathematics. So therefore, now when we come across the topic, that is the first topic, numbers and everyday math, the first thing that we should know, and that is the thing that we will be discussing here, we will discuss all those topics, all those questions which are necessarily to come in your paper. So you have to take advantage of all the classes that are being conducted here, and that will definitely be helping you. So I'm starting with the first one. When we say numbers in everyday mathematics, you get different types of questions, in which the first question is related to the categorization, meaning we categorize the numbers. And the most important category of the numbers that we are going to do is the prime numbers, because normally all the calculations depend upon the prime numbers. And how do we know that what numbers are said to be the prime numbers? That is the first thing that should be in your mind. And that is said to be that the prime number is that number having two factors only. One factor will be 1 and the other factor will be itself, meaning you will find that a prime number will be that number which can come in only two tables, 1 and itself. If you have factors less than 2, then also we don't call them prime numbers. And if they have factors greater than 2, then also we don't take them as prime numbers. Okay, so the first prime number appears in the list to be 2, then 3, then 5, then 7, then 11, then 13, and so on and so forth. Now you can see that these numbers are there, which can only come in the table of 1 as well as their own self. They can't come in any other table. Now, when the question comes related to the prime number, they can be of 3 types. Now, watch carefully. And if you have, it is better that you should have some writing material in front of you so that you can do this copying, because you can screen share, you can capture the screen also. That is also good. And we will have the recording, so we can share the recording afterwards. But right now, I would rather suggest that you should have some writing material with you. When you do some writing, it directly clings to your mind, and that helps a lot to remember that. So now when we say, when I said that there are 3 questions or 3 types of questions which can come in relationship with the prime number. So out of them, the first one is write down all prime numbers. Write down all prime numbers between 21 and 32. Now, this is one question that you will find normally every year paper one. Maybe it must be the third or the fourth question or somewhere in between, but they normally appear there. Now, what we have to do is we have been provided with the limits in which the list is there. And out of that list, we have to pick out only the prime numbers in between them. In between them means these numbers which are at the border will not be included in that list. Okay, so right now I have taken those numbers which are not already prime number, so there will be no confusion. But we should be aware of that if these two are also the prime numbers and this question is written, then we will only take those which are lying in between, and we don't take these limited values also, limits values also. So we have to think of all the numbers in our mind, analyze, and just see what are the prime numbers. So first, starting with this, 21 we shouldn't take. 22 will be there. 22 is not a prime number because it comes in the table of 2 and 11 also. Then the first prime number in this list is 23. Then comes 24. It comes in the table of 2, 3, 4, and 6, and 8. So it is not a prime number. Then 25 comes in the table of 5. 26 comes in the table of 2 and 3. 27 comes in the table of 3, 9. Then 28 comes in the table of 2 and more. Then comes 29. 29 is a prime number. So we'll take it here on the list, that is to be included here. After 29, then 30 is there, which is an even number, so it is not a prime number. Then 31. 31 is there as the prime number. Yes, good. So all these numbers which we have seen right now will be the answer of this question. Now see, same question can be written or can be given in this way. Now that is a very important thing to understand. How many prime numbers? How many prime numbers lie in between 21 and 32? Now the same question is there, same limitation is there, but the wordings of the questions are now changed. Now you just have to think. And that is a very important thing they give in the examination, these type of questions in which the students get confused. It is said, how many prime numbers lie in between 21 and 32? Again, you have to analyze and see these prime numbers should be in your mind. But what you have to do is, you will not write these three numbers there. If you write, then it is an incomplete answer. You have to count them, 1, 2, and 3. And you will write number 3 here. You have to write down the number of the prime numbers that are appearing there. So there, in this question, you will have 3 as the final answer. I said there are 3 types of questions which come as the requirement. Now just see what will be the next one. Next one, I'm writing down here just along with this first question because it is comparison to this and a very important thing to be noted. And what is that important thing? That the question will be, write down all prime numbers. Write down all prime numbers between 21 and 32. Let's not take 32, let's take 31. 21 and 31 inclusive. Now this word inclusive means you have to take the boundary numbers also, because in the First example, I told you that we have to take only those numbers which are lying in between this, and the boundaries should not be taken. But in this question, this word inclusive tells us that we have to take the boundary values as well. So now here we will have 23, 29, and 31. But suppose if this inclusive word must not have been there, then the answer must have been 23 and 29. Inclusive word has actually indicated the values to be considered as the numbers to be included. Beta boundary numbers means the numbers which are given there as is, like 21 and 32, they are the boundary numbers. Like 21 and 31, they are the boundary numbers. As I gave the example, when it is not set inclusive, they just say write down all prime numbers between 21 and 31. Then this will be the answer. That means this 31, which is in the border, that means in the limitation of this list, that will not be included. But if they say inclusive, then we have to include that also. The border numbers are these numbers which are given here for the list. Okay. So these three questions must be in your mind, and just keep this strictly in your mind that this is the pakka question that will be coming in your examination this year also. And I will definitely be giving you all those special questions also, discussing all those special questions also, which will or which are going to come in this examination. You can mark those questions with the static or some highlight, and that you have to definitely prepare in our examination which are coming. So this is the first one that we have right now done. Now moving along, as I said, the prime numbers are the main suspect of every calculation. So it starts with the prime number, we should know, and then we move on. If the numbers are not prime, then they are composite. But normally you don't get the questions of the composite numbers. So you just know this meaning or the definition of it. That the composite numbers are said to be those numbers which are not prime numbers. Okay. And the composite numbers normally start with 4. 4 is the first composite number. 4, then 6, then 8, then 9, 10, 12, 14, and so on and so forth. Many numbers are there till infinity. Now, a very, very important question again, which I would rather say that will come definitely in the paper, and paper 1 is said to be the irrational numbers. Now, by looking at the name, it seems very difficult to understand what is irrational number. But you have to understand this thing, and you have to keep this in your mind that the irrational numbers are there. So first of all, no need to think about this, of what are the rational numbers or what are the irrational numbers, or no need to get into the definition of it. You just have to remember this thing, that if a prime number is in the square root sign, I mean it, square root sign, not the cube root sign. If the prime number is in the square root sign, then that is called the irrational number. If a pi sign is there, pi symbol is there, then that is also an irrational number. Now, how do you get the question in it? Just see. Again, the first and the most important question, they ask you, write down or find all the irrational numbers find all the irrational numbers between 2 and 3. Find all the irrational numbers in between 2 and 3. Now, 2 and 3 are already two numbers that we already know that the integers. And if we are looking for some values which will be in between, then definitely or obviously it should be the decimal values. But if we take the decimal values, so there are so many definite decimal values that we can't take all of them here. So the main method of resolving this kind of situation, this type of question, is take the help of this definition of the irrational number. What you do is I will give you the answer of this, beta. 3.142 is not an irrational number, but pi is an irrational number. So you get confused in this thing that pi and 3.142 are same, but they are not same actually. They are different. So pi is an irrational number, but 3.142 is not an irrational number. Okay, now let's come to the question how to solve this. Again, we have got the boundary values there, border values given there, for which we have to see that how many irrational numbers lie in between. The method is there that we convert these two boundary numbers into the rooted form. 2 can be written as square root of 4 because we know square root of 4 is 2. The same way, 3 can be taken as square root of 9. That means square root of 9 definitely is 3. So we have to write first of all the boundary values in the square rooted form, and then in between write all the numbers which lie in between these two values in the square root, like this. After square root of 4, we get square root of 5, then square root of 6, then square root of 7, and then square root of 8. There is no other number after that. So this is the list that we should have. Now, looking at the definition of the irrational number, we can pick that square root of 5 will be an irrational number and square root of 7 will be an irrational number. So these two are your answers. Again, they can ask a question in this way also. See, how many irrational numbers, lie in between 3 and 4? How many irrational numbers lie in between 3 and 4? Again, just read the question carefully, and they are asking you how many. You have to count all the irrational numbers and write down the figure there. Count all the irrational numbers and write down the figure there. And how will that be done? Just see. Again, take the process of the same that I have given you instruction in the beginning, that write down the square rooted value of the boundary numbers. Square rooted value of the boundary numbers. Just see. It will be root 9 and root 16. Root 9 and root 16. And how do we resolve now? After writing this, we'll write down all the values which come in between root 10, root 11, root 12, root 13, root 14, and root 15. Now, coming on to recognition of the irrational numbers, square root of prime numbers. That means root 11 will be a prime number. Root 13 will be a prime number. We can't see any other prime number here in the square root. That means only two irrational numbers are there. The answer for this question will be 2. That means count the irrational numbers and write down the figure that comes in the counting, and that will be your answer. Okay, got it? Irrational numbers, prime numbers, these type of questions are there. They are related to the categories. It means they are related to the identification of their category, and then how to recognize it. Moving forward to the other calculation now. Again, a question comes related to the prime numbers or the prime factors. Yes, beta. The thing is that whenever we do this question, find all the irrational numbers between 2 and 3, means what you have to do is the boundary numbers are to be taken, and they are first of all to be written as their rooted form, meaning if 2 and 3 are there, 2 can be written as square root of 4, 3 can be written as square root of 9. And then what we do is we write all the numbers which come in the list in between in the square rooted form. Root 4, then comes root 5, root 6, root 7, root 8. And what we do is we will just check those numbers which are the prime numbers and they are coming in the square root. We check those are said to be the irrational numbers. If it is asked how many irrational numbers are there, we count them and write down the figure that comes in the counting as 2 or 3 or 4, whatever they are. Moving forward with the prime numbers, as we know that all the calculations definitely comprises of the prime numbers, then one more question comes, and that is they ask you to convert some value, like it is said, convert 324 into product of prime factors. Product of prime factors. Now, again, an important thing, the terminology is used. The product of the prime factors actually means we have to first of all take out all the factors. Means suppose if 324 is there, we have to see in which table 324 comes. Okay. Then we have to see and check whether those factors are the prime factors or not. If they are prime factors, then we take them. And if they are not, then we reject them. And then we multiply all of them together in such a way that they should get to the answer 324. So it will take a longer this process of thinking. Instead of doing this thing, what we can do is we'll take out the factors like this. See, we write it in this way, 324. And then we take out the factor. Normally, you people call it LCM, but this is not LCM. This is a simple factorization method. Just see. Yes. So I was saying that this is the simple factorization method. Okay, beta, just keep one thing in mind that normally that Zoom session ends after 40-minute session. You must have seen the timer also running. So today, when this timer ends, you will rejoin with the same ID. That means today we'll be having the 1 hour class, but it will be in this way that as soon as this Zoom session ends, you rejoin quickly. I will rejoin with you people. Okay, so when we are doing this 324 in this situation, that is, we are taking out the product of the prime factors. What you will do is you will quickly convert this into the prime factorization form. And you must be aware that we do the table and we think about the table. In the table of which this 324 comes. The 324 is right now the even number. We know that even number will always come in the table of 2. So we start with the 2. And then we think about the values which will be substituted for 3. That is, I will see in the table of 2, 3 never comes. But in the table of 2, we get 2, and that comes at 1. So 2 are there. 1 is still left because it is not used. This 1 will be combined with this 2 to make it 12. And then we see in the table of 2, 12 comes at 6. Then in the table of 2, 4 comes at 2. So actually we are dividing 324 by 2 to get this 162. Again, we will take the same process and we think about the number that again, this is an even number. So that will go on with 2. And now it will be 2 8s are 16 and 2 1s are 2. Now, since this is not an even number, and why it is not an even number? Because the last digit is not an even number. If the last digit is an even number, then the whole number is an even number. If the last digit is an odd number, then the whole number is an odd number. Now, since it is not an even number, so it will not be divisible by 2. So the next thing that should be taken here, the next number should be taken. No, wait, we will not take number 9. We have to take prime numbers because it is said product of the prime numbers. Therefore, we have to take only the prime number. 9 is not a prime number. So we will take the number which can divide this 21, and that number will be 3. Then again think in this way, where will this 3 lie in? Where will this 81 lie in the table of 3? That will be 3 to the 6. And then 2 left, that will be combined with this one to make 21. That will be 3. 27s are 81. Again, that will come in the table of 3. 3 9s are 27. Again, in the table of 3, 3 3s are 9. We will continue this process till we get 1 at the end. As soon as we get 1 at the end, that is the end of our process of factorization, we will stop there. And how do we write now the values that we have already got here? And that will be written in this way. 324, that is the answer, is equal to 2 times 2 means 2 square. We write them in the index form. This is called the index form. That means the powers are there upon each factor. That definitely will be helping us in the forthcoming calculations. Then 3 is appearing here 4 times. So it will be 3 to the power 4. 2 square into 3 to the power 4. These are the product of the prime factors. If you multiply them together, you will find that they will end up with 24. You can see that all of them are prime numbers and they are all the factors of 324. Okay. Just see another example. And this example, you people will do. I just will give you 2 minutes to do the factorization process, and that is convert 1024 into product of prime factors. Better, since maths is only related to the practice, that is why you people also have to participate. So you will convert this into the product of the prime factor quickly in 2 minutes. After 2 minutes, I will write down the answer here and you people will check whether your answers are matching mine or not. Okay, your time starts now. Those who have finished, they can just message, write the answer on the message, or they can just say that you have got the answer, and then we'll see that who are the people who can do this fast and who are the people who can't do these calculations fast. It's not necessary that the faster people will always win. I'm just doing it in a way that you get the practice of it. I'm not just using this for criticism for anyone, but it is just that you have to increase your speed also when you do the calculation. And you, when you will be with me, I will definitely make you do questions in front of me as well as at your home. So it will be a good thing for you people to take advantage of these things. And inshallah, you will find that at the end of our session, every session, you will definitely be gaining some knowledge. And that is the main task. Everyone will gain some knowledge in every class, in every session. And at the end, obviously, you people will be there to participate in your CAIE examination, and 100% you will be getting very good marks in the examination. Okay. 1 minute is already over now. Oh, one student has got the answer. Oh, good. 2 students have got the answer. Good. That means they have a good speed. Others also definitely will get to the answers. Your time is nearly getting over. 3 students have got the answers. Okay, beta, stop writing. That means those who are doing, okay, 4 students have given me the answer. But the last student who had given the answer, beta, you should write it as a power of 2, not in this way, but I know that it is not written there. That is why you are doing this thing. Yes, beta, inshallah, the whole syllabus will be covered in this crash course. We'll be having this class every day at this time. And at the end of our, before the examination, inshallah, before your paper 1, I will try my level best to complete the whole syllabus, and definitely it will be covered. We will try to take the topics in a way that they are according to the precise list of our priority, meaning the questions will come and that will be actually related to the paper. Yes, you will also have the mock examination, and that will be when we'll be covered with the syllabus. That means when we'll be over with the syllabus, and you will definitely get the results also, because without the evaluation, without the mock, without the test, you can't judge yourself whether you have got the things in your mind or not. Obviously, it is a free education, beta. No one is asking you or demanding you for any fee. This is for everyone to attend and hear. Whoever the teacher is, whether it's me, whether it's the other subject teachers, they are all providing you this workshop free. All the syllabus covering and all the things. In fact, we will be giving you the worksheets also to do. That will calculation. Now, as it is said, hence evaluate square root of 1024. Square root of 1024, then you don't have to use any further calculation, or the calculator definitely cannot be used, but you will take help of the factorization that you have already done. And how will that be done? Just see. Square root of 1024 can also be written as square root of 2 to the power 10. Right? Square root. When the square root is there, then the process is we will divide the power of every factor by 2. And then in this way, we'll get rid of the square root sign. Once we are getting rid of the square root sign, that means we are dividing the power by 2. See, I have divided the power by 2 and I have taken out or removed this square root sign. So the final answer will be 2 to the power 5, or we can write it as 32. I'm taking one more example so you will understand this thing. See, if this is the first part of the question, convert 324 into the product of the prime factors. The second part is hence Hence, evaluate square root of 324. Hence, evaluate square root of 324. Hence means taking help of the previous part. Evaluate means find the value in the number form, numerical form. No algebraic calculation, no variable, no plus minus sign should be there. So now this will be in this way. We'll take 324 in the square root and substitute it with the prime factors that we have already acquired. That is 2 square and 3 power 4. Now, it is said in the question that we have to find out the square root of 324. So we have first of all converted this into the simple form, which is the form of this product of the prime factors. Now, the method is you have to divide each power of the factor by 2 in order to get rid of the square root sign. And how will we do this? Just see. First thing, 2 to the power 2, and that power 2 is divided by 2. Always divided by 2 because of the square root sign. 3 to the power 4, and that 4 is divided by, again, a 2. And the square root is removed. Now just simplify. This 2 and this 2 in the fraction will get cancelled, and we have 2 to the power 1. This 2 and this 4 get cancelled, and we get 3 to the power 2. So if you simplify this, it will be 3 square means 9, and 9 twos are 18. 18 is the square root of 324. Got it, beta? Those who were asking me to repeat, I have repeated. Okay. Now, when the square root thing is there, the same type of situation is for the cube root. Just see. Another question. The first part, convert 216 into product of prime factors. And then the second part, hence, evaluate. And consider those things that when the wordings of the questions are there, they are very important, especially for those students who are hoping best to get there, meaning either the A students, or distinction holder students. And mind it, distinction is not a very difficult task. It can be acquired by you people also, just with the consistent efforts. This is cube root of 216, not the square root. Now, starting with first thing, 216. I'm doing it in this way first, factorizing 216. We can start with 2 again because 6 is the last digit, which is the even number. It tells that 216 is an even number. So I'm starting with 2. In the table of 2, 2 comes at 1. Then 1 is there, but 1 is not available in the table of 2. So we have to combine it with 6 to make it 16. But this cannot happen without doing this method of adding a 0 here. Without adding a 0, you cannot just make this 116. So 2 8s are 16. That is there. And then we'll take again the 2. 2 5s are 10. 2 4s are 8. Again, since 4 is there, that is the even number. We will take 2 again. 2 2s are 4. 2 7s are 14. Now this cannot go with the 2, so we will have to take 3 here. 3 9s are 27. Again, 3 3s are 9. And again, 3 1s are 3. So the product of prime factor for the 216 will be 2 cubed into 3 cubed. Okay, this is the prime factorization. Now we'll make use of this in the second part of the question. Cube root of 216. It will be done in this way. Cube root of, we'll take the help of the factorization, 2 cubed into 3 cubed. As I told, to get rid of the square root sign, we will divide each power by 2. And same way, to get rid of the cube root sign, we will divide each power by 3. This is the method. So cube root sign is not taken. This 3 will also be divided by 3. And this power 3 will also be divided by 3. And cube root sign is gone. This makes power 1. This makes again power 1. So 2 times 3, 2 3s are 6. 6 is the cube root of 216. 6 is the cube root of 216. How can you check? You just have to check it in this way, that you multiply this 6 3 times together. 6 into 6 into 6. And you will get the answer as 216, and that will be the proof or the evidence that the cube root of 216 is 6. Okay, beta, got it? So I am just ending this class today here. And we will continue with the next class things in the next class, that is tomorrow. Okay, so all of you take care of yourself. Best of luck and Allah Hafiz. We'll meet inshallah tomorrow.